Okay, so the purpose of this video is to help you to go on Khan Academy and get 5 in a row on the activity Understanding Logarithms as Inverse Exponentials. And so what they're trying to get you to understand is that if I have the log base b of x equals y, that's the same as b to the y power equals x. Okay, those are the same. So notice I just took the b, raised it to the y power, and set it equal to x. Well, if they give me this, I need to be able to take this and turn it back into that. Okay, so in this case, on this first one, it says rewrite the following equation in logarithmic form. So they give it to me in this form, and they want me to convert it to that form. Okay, so notice the b in this case is 10, and the y in this case is -1, and the x in this case is 0.1. So let's rewrite it. Okay, so it's log, and the base is 10, right? Because notice that the b is the base, and then the x, okay, the x in this case is 0.1, and that equals -1. And so what we're saying is we're saying 10 raised to the -1 power equals 0.1, which is what we have right here. 10 raised to the -1 power, just like they have here, equals 0.1. So we converted from this form to this form. Okay, now down here, it says rewrite the following in exponential form. So notice this is logarithmic form, and this is exponential form. So let's do it. So we know our base, 5, that's our base, raised to the 6th power is going to equal 15,625. So all I did is I took the base, 5, raised it to the 6th power, and that gave me 15,625, which I wrote right here. It's important that you understand and memorize that this is logarithmic form and this is exponential form, but this is exactly equivalent to this. We call them inverse. Okay, so let's look at this one. So up top, right here, it says rewrite the following in logarithmic form. So you know your base right here is also, the base of the exponent is also going to be the base of the logarithm. So log base 10 of all this, 0.0001, has to equal -4. And if you want to check it, you can type in your calculator log base 10 of 0.0001, and it should give you -4. And so now let's look at this one. It says rewrite the following equation in exponential form. So we know we have our base 96 raised to the 1.2 power, and that should equal 239.18. So let's do that. 96 raised to the 1.2 power should equal 239.18. And the way you can check and see if you did this right is get your calculator out and raise 96 to the 1.2 power and see if it equals this. And the top one, you can get your calculator out and do log base 10 of 0.0001, and it should equal -4. Now remember in your calculator, if you just put in log of 0.0001, the understood base that's not written there is a 10. So if they do not write the base, then it's understood. Everybody knows it's a 10. So let's look at this one. So it wants us to rewrite the following equation in logarithmic form. So you can see our base is 10. So let's go ahead and write our log with a base of 10. And it's of 0.01. And that equals -2. Okay, right here on the second one, it says rewrite the following equation in exponential form. So we're saying our base is 7 raised to the 2.7 power. Our base of 7 to the 2.7 power equals 191.322. And I encourage you to get your calculator out and raise 7 to the 2.7 power and see if it equals this. All right, so on this, we have two different tables. Table 1 right here and table 2 right here. And what they're trying to get you to understand is b to the x power, okay, is the inverse of log base b to the y power. This is the inverse of this. Okay, so what we're saying is some base, all right, raised to some exponent, which would be like 0.827, is going to be 5. But look up here. The same base, okay, raised to that same exponent. So here would be the exponent and here would be the base. Notice I've got my output's 5 and my input's 0.827. Well, here my input's 5 and my output's 0.827. So it's real easy. The reason why it says here you do not need your calculators, they're trying to get you to understand it's the inverse. Notice when the input's 1, they want to know what the output is. Well, look right here. When the input's 7, they got out 1. When we put in 1 here, we get out 7. So 7's the answer for that blank. Okay? Here they want to know what input can I put in to get out 9. Well, if I put 1.129 in, I'll get out 9. So the answer here is 1.129. It's that simple. They're trying to get you to see it's an inverse. Okay, so when I put in 1.318, I get 13 out. So now they're saying, what can I put in to get 1.318 out? Well, obviously it's 13. And here they're saying when I plug in 1.456, I get out 17. So here I'm saying when I put in 17, I should get out 1.456. So I'll put 1.456. This is why they're saying up here, you do not need a calculator, because they're just trying to get you to understand that b to the x power is the inverse of log base b to the y power of y. So what you should do now is you should pause the video and see if you can fill this in and then replay it. So notice right here, my input's this, my output's this, my input and output. So here I've got 10 goes with 1, so 10 has to go with 1. 25 goes with 1.398, so 25 has to go with 1.398. 40 goes with 1.602, and so 1.602 is going to go with 40. 2.602, we don't know what it goes with, but here 2.602 is with 400, so I'm guessing it's with 400 here as well. And if you type all these in Khan Academy, it'll count it right, because this is the inverse of this. Okay, let's look at this one. Same thing. B to the x is the inverse of log base b of y. So 3 goes with 0.683, same here. 5 goes with 1, so 1 goes with 5. 8 goes with 1.292, so 8 right here goes with 1.292. 10 goes with 1.431, so it does as here as well. And 12 goes with 1.544, so 1.544 here as well. And now they want you to understand the input-output inverse relationship when graphing. So you've got y equals b to the x power, which is the inverse of y equals log base b of x. This is the inverse of this. And so you can see right here, this is the point, this right here is the point 1, 0. Well, the inverse of 1, 0 is going to be 0, 1 right there. And so right here I've got the point 4, 1. See, I went right 1, 2, 3, 4, and up 1. Well, the inverse of that's going to be up 4 and right 1. So I need a point right here. And then this point over here, 16, it's right 16 and up 2. Well, the inverse of that would be up 16 and right 2. Okay, so right here. So this these points, making this graph right here, is the inverse of this graph right here. So now I would encourage you, okay, so look at this graph. So this point right here is right 1 and up 0. So the inverse point of it would be up 1 and right 0, right? This point right here. Okay, so the second point, this one, is right 2 and up 1. So the inverse of that would be up 2 and right 1. So I'd need a point there. Okay. This point right here is over 4 up 2, so the inverse of that will be up 4 and over 2. Right there. Okay, this point right here is right 8 and up 3, so the inverse of that will be up 8 and right 3. So right there, and this last point is over 16 and up 4. So I need to go the opposite of that, up 16 and right 1, 2, 3, 4 right there. And so I've drawn the graph that is inverse to the graph they provided. All right, so here's our last example. So this point right here is the point 0 and up 1. So the opposite of that will be right 1 and up 0. Okay. This point right here is right 1 up 4. So the inverse of that will be right 4 and up 1. So right here. And this point up here is right 2 and up 16. So the inverse of that's going to be right 16 and up 2. So right there, let me put a point there. And so the graph I've drawn, this point, and this point are inverse to the 3 points they provided. And now what I'd encourage you to do is go to Khan Academy or Google and search Khan Academy and then Understanding Logarithms as Inverse Exponentials. And now that you watch this video, I think you'll be able to get 5 in a row very, very quickly.